Hello! Today we're going to look at the Gone Fishing chassis strength test. The preliminary strength test, that is. Like, this is just a example during the design that I do. And we're also going to have a look at the defamation setting that's used in the FEA, just to see how we can get more information out of the FEA. Also, I'm going to have a look at some simple dimension stuff to keep in mind while we're designing. So just for this study, we can see that we've got all of our parts set, all of our materials, which is just to carry through in SolidWorks if you've got all your materials set in place. I have used a bunch of contact sets here to make up for missing welds, as I've described before, mainly for the rounds in steel. We've got our gravity in place, 9.81. We've got to have our gravity in place for this, for the distributed mass, which we've got the 3.5 on because we're using a tandem setup. So the gravity is important. I think I've said before that you can use force in these situations, and you can break the mass up into a front load, middle load, rear load. Because this is just a preliminary study, we're simply doing distributed masses. We've got our von Mises sets to 115 as our top. We've got 460 as our limit, but we want to try to maximize our safety factor. So I want to get about 115 out of it, because then I know that it's still safety factor 3 at G350 steel, but we're going to use G460 as these rails, and only the cross members will be 350. Okay, so you can see that like no force is absorbed into this rear rail. I want more force absorbed through those center rails, so we'll do a redesign that'll hopefully push a little bit of force into the center rails. Into the cross members, mainly because, see down here, we've still got higher numbers than the 115. I think it peaks out around like 188, 190, but we don't want those sort of numbers in there. That destroys my whole safety factor thing. So I've got to try to get those forces down a little bit, and I want to do that by passing the force into the members that are less affected there. So of course, when you're designing your trailer and stuff like that, there's a few simple things that we've got to keep in mind. Mainly just dimensions. All of these things are set out in VSB1 and in the ADRs. And if you can get your hands on it, to the code of practice for RV map. So here you can see like this, there's a few simple dimensions like to keep in mind during your design and stuff like that. You don't want to go too far with your drawbar. Your overall length to keep in mind. Your rear overhang, obviously always really important, because you've seen how that rear overhang suffers the most in its FEA. Widths, obviously, many things to keep in mind with widths. The ground clearance, obviously, for your mud guards and everything. Height maximums include your air cons. For widths, include your awnings. Also keep an eye on things like, this doesn't really matter for design as much as this matters for just the number of chains that you need to put on. But I think that everyone should, have a look at VSB1 and look over the chain laws so you can inspect your vehicles yourself. Just make sure that you got the right equipment on there. These chains are all set out to their ratings for a reason. So, especially with a lot of import stuff around. So anyway, now we'll have a look at deformation in the FEA. So you can see there, like I normally just use a standard deformation, or like normal sort of real form sort of thing. So that's like the sort of deformation that you'd see in real life. But I want to try to find a way to put more force into that center area. So you can see on the automatic scale, it has like we're number 1 on true scale, and on automatic we're like 100 and something. So if we go to this automatic scale, we can see that it deforms the model a lot more to really accentuate those forces and give you a better idea of how those forces are working into it. Like we can see that, why is it red there? Because we've got too much drop off on that rear end. And you can see sort of like the curve in the chassis is already there at the front. So, you know, putting more weight to the front's not really going to help counteract that as much at the back. You can see that this center rail in particular there is absorbing a lot of force. And that's what I want to try to get off the rear, by pushing some of that force into the cross members, which I'll show in another video how we're going to do that. And you know, it shows here on these outside members too that don't show a lot of force in the actual FEA or in the von Mises scale, whereas you can see there now with the deformation set up a lot, that twisting sort of motion, that part there. So it's not doing anything really to help diminish that force. You can see that it's not much force is going through into it. So there's things that we could do there to try to diminish that too, you know, possibly make the wheel arch here. If we can make that wheel arch like part of the chassis design, so it's, you know, it's welded in and part of the galvanization process and everything like that, then we might be able to absorb a bit more force out of that rear end there and stabilize those outriggers to help absorb the force more as well too. And now I just show that, so you might see in the true scale, you might be looking at the true scale thinking like, oh, there's no deformation in that. No, it's true scale deformation. So if I'll reset to that and show you that that there's still deformation in the model at true scale. It's just sometimes a lot more minor, and you sort of got to look for it a bit more. So you know, the scale of deformation is all that we were playing with before. So you can see there at a direct view from the back, we've still got curvature. Oh no, wait. Perspective, but still, you know, I'll recenter the camera. Yeah, but you know, still, see, you can see the deformation still remains in it, and you can measure that, you know, to check your deformation, compare it to real life, or you can just add mass in real life. If you've got the luxury of having a prototype, then obviously real life testing and everything is one of the best ways to measure real life deformation, but FEA gives us a good way to try to do that as well too. And I've got access to a few more different study types now in FEA, which I'll try to do some videos on in the future. So, you know, I can do the dynamic studies and such as well too. I don't bother to do safety factor studies because you can just do it by calculation. It's really not that difficult. So having a whole aspect of SolidWorks devoted to trying to get it when you've already got the stress like here in front of you, we can plot another thing to look at safety factors, but yeah, it's not really worth it in my opinion, because as I said, we can just do it by calculation, which I do include in my reports then and stuff. So yeah, we want more force into those sender members, and that's it. Please support Hunter Caravan Designs by following our Facebook group. There'll be links for that after this. I'm trying to build a website, so it's taken a bit with videos and everything. You can contact us on Facebook if you need anything done, if you want models done or anything like that. Please contact us. Always happy to build caravans or talk about caravans. So that's all. Thank you very much for watching. Bye.